Hi and welcome to Pre-Calc 20 with Miss Verity. Today we're going to be looking at 4.4 The Quadratic Formula. So basically with the quadratic formula, you can simplify or solve any quadratic equation, no matter what. So factoring is typically the one we use first because it's the fastest way, but it can't solve every scenario because some things are not factorable. So for that, we're going to use the quadratic formula, which is this beautiful one where all our equations are in this form: ax squared plus bx is equal plus c is equal to 0. And our quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So to start, a couple things to know. So we have to get it into ax squared plus bx minus or plus c, I guess, in this case, where our a is equal to 2, our b is equal to 7, and our c is equal to negative 85. So quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4 times our a times our c all over 2a. Okay, so now we're going to simplify wherever possible. So we've got negative 7 plus or minus the square root of 49 plus, in this case, I would not expect you to necessarily do this without a calculator. This is quite large numbers, so on a quiz or a test, I wouldn't do ones this large. All right, so if we continue, negative 7 plus or minus the square root of 729 all over 4. Well, let's check if 729 is a perfect square. Take the square root of that, if I can figure out how. And that happens to be 27 squared. So negative 7 plus or minus 27 over 4. I'm just going to move back up to the top of my page. So we're going to have two sides, negative 7 plus 27 over 4, and x is equal to negative 7 minus 27 all over 4. So 27 minus 7 is 20 over 4, which is equal to 5. And on this side, we've got, this is going to be negative 34 over 4. 4 doesn't go in perfectly, so we're just going to reduce where possible. So if I divide that by 2, 34 divided by 2 is 17 over 2, and there's negative. So solution set, lowest number first. There we are. So next example, same thing, putting in our ax squared plus bx is equal to c form. So I'm going to add 10x squared to both sides. So I'm going to get 7x squared plus 12 is equal to 0. And you might look at this and go, okay, well, I know 7's my a, but that's probably my b, right? Well, no. It's always our ax squared, so our x squared term plus some linear term plus our constant term. So in this case, what we really have is 7x squared plus 0x plus 12 is equal to 0. So to solve, x is equal to, well, negative b is just 0 plus or minus the square root of b squared minus 4 times a times c all over 2a. So x is equal to 0 plus or minus the square root of, this is going to be 28 times 12, negative 336 over 14. So this is where the bells are going off in your head and you're like, I can't do this. I cannot take square roots of negatives. And you would be correct. So in this case, because there's a negative under our square root, no solution. So that could be one way your answer looks. You could also do the 0 with a line through it, or you have empty squiggle brackets. All three of those things all mean the same thing. When you get a negative in your answer, typically, honestly, check up here and see if you lost a negative first. So rather than going, oh, I'm done, if you're on a quiz or a test, check for that little mistake. Okay, and our last example. So if you look at this and you go, oh my gosh, fractions. That's okay. We're going to work at ways to work with fractions so we can improve those skills. And especially because you don't want fractions in your quadratic formula because you can, go for it. But you're going to end up with fractions over fractions, and stacked fractions are yucky. So what you might want to look at is what could you multiply this by in order to get rid of all of your denominators. So if you're looking for a common factor between 4 and 6, I would say if you multiply everything by 12, that's going to cause your denominator to go away. So what I'm going to show you what that looks like. So what I'm going to do is I'm going to multiply each by 12. But by doing that, I'm going 3/4 times 12. Well, that's really 12 over 1. If I was to multiply this, I would have 3 times 12 over 4. And 12 is really the same as 12 is 3 times 4, and there's already the other 3 over 4. Well, the 4s are going to divide. How I might show that in a quicker way would be 3/4 times 12. Well, I'm just dividing each by 4, and I'm left with 3 at the end. So in this case, I'm going to be left with 3 times 3, which is 9, plus 2 times 12 is 24, minus 1/6 times 12. Well, 12 divided by 6 is 2. So I'm left with 2 minus 2 is equal to 0. So again, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, but in this case, a exists, and 2a. There we go. Negative 24 plus or minus the square root of, b squared. 24 squared, 576, plus 4 times 9 is 36, times 2 is 72, all over 18. So negative 24 plus or minus the square root of 648 over 18. I might check right away, is 648 a perfect square? I don't think it is, and it sure is not. So a couple ways. You can either look for the greatest perfect square that's a common factor. If you don't want to necessarily do a bunch of guessing and checking, we could break this down. So 648 is going to be 2 and 324. If I break that down, it's going to be 2 and 162. If I break that down further, 2 and 81. Well, if I go right there, I know 81's a perfect square. I also know that, which would be 4, is also a perfect square. So negative 24, square root of 81 is 9, and square root of 2, or square root of 4 is 2. So 9 times 2 is 18 root 2, because this 2 was left over, all over 18. Again, you could have broken this one down further, got 9 and 9, 3 and 3, 3 and 3. There's your group of 2, there's your group of 2, there's your other group of 2. Okay, so then last thing, we want to check all of our coefficients, see if we have common factors, and yep, we sure do. In this case, 6 is common to both, so I'm going to divide each coefficient by 6, and I'm going to get x is equal to negative 4 plus or minus 3 root of 2 over 3. And that would be our final answer. The only difference with the quadratic formula between this and Foundations 20 is that we are leaving everything in exact values. We're never putting anything into decimals.